In this section of the DVD, what we're going to look at is modeling with polygons. This is a pretty important section of the DVD because what we're looking at here is modeling with raw polygons. A few years ago in 3ds Max, the toolset wasn't fantastic for doing this, and therefore this was something that I came to later in my modeling career. And back in the day, the main methods you used for modeling were things like creating a primitive, bending it, doing some minor modifications, using various modifiers, and then you would piece things together. And it was actually very difficult to do organic models. But with the advent of sub-D modeling technology, which was pioneered by Pixar, it became much easier to do organic modeling in pretty much all 3D packages. And these days, pretty much all organic modeling is based on either sub-D modeling or taking a sub-D model, then sculpting that in great detail in a package like ZBrush or Mudbox, which is a new package which is on the market pretty soon. Being able to polymodel these days is a very key feature. If you go for a job in pretty much any film studio or a games company or TV, you're going to be asked to do polymodeling. It's one of the key things. Primitives are a great way to start modeling, but they're not really going to be that useful for when you're doing any kind of organic modeling. If you're doing technical modeling, modeling mechanical objects, then things like spheres and tubes are very, very useful, and they can be very easily, a part of a model. But when you're talking about organic modeling, polys are the king, and having good poly modeling skills are very, very important. And in this series, we're actually going to hit on polymodeling in two different ways. In this DVD, we're going to look at pure polymodeling. We're not really worrying about subdivision surfaces or anything like that. We're going to look at that in the third DVD in this series. And in the second DVD in the series, we're going to be looking at splines. So we're not really going to be concentrating on polygons in that DVD. But for now, we need to look at basic polymodeling. For us to do that, we need to quickly recap what the two different mesh types are in 3ds Max. So let's do that now. In 3ds Max, we have two main polygonal mesh definition types, or base object types as they're known more officially within Autodesk. The first is the edit mesh, and this was created for the first release of 3ds Max way back in 1996. The second is called the editable poly, and it's a newer architecture that was added in release 4. Let me give you an overview of each system and how they are made up. It will make the next three chapters make a lot more sense as we're going to be looking at basic mesh editing, as I said earlier. So we really need to understand what the difference is between edit meshes and edit polys. In this chapter, we're going to look at the edit mesh, so let me give you a definition of what that is. The edit mesh is a basic triangle polygon based mesh. It has very few rules and has a very basic internal storage structure. By a lack of rules, what I mean is that all the faces in an edit mesh are triangles, and any edges of a triangle can be shared with an unlimited number of other triangles. Also, all of the elements of the edit mesh are dumb. What that means is one poly has no concept of any of the other polys around it. A vertex doesn't really know about the other vertices around it or the edges which are connected to it. It's simply a list of triangles that are made up of verts and edges. This simplicity has two main ramifications. The edit mesh object type is very fast for a graphic card to display, and that's with Direct3D or OpenGL. The second point is the lack of neighboring topological information makes it very, very slow for doing sub-D modeling, which is why the edit poly was introduced. In subdivisional modeling, as you can tell by its name, the system is based on taking a polygon or polygons and then splitting them or subdividing them. And the calculations needed to do this subdivision on one polygon isn't really, that difficult for a piece of software like 3ds Max with an edit mesh. But the idea behind sub-D modeling is that when you're splitting a mesh to add detail to it, that this subdivision takes place along ring of polygons. And as edit mesh polygons have no concept of the edges that are near to them, working out what are the edges in a ring is very difficult. There's no obvious way of doing it. So you have to do this really laborious search through all of the edges in the mesh. This takes quite a long time. Now, we're talking about computers here. When I say about a long time, it might be milliseconds or whatever. But when you're talking about hundreds of edges or tens of edges, and when you're talking a mesh with a lot of polygons in it, then working out those edges which are in a ring is probably going to take quite a long time, and it's going to be humanly discernible as being a long time. It might take 1 second, 2 seconds. That may not sound very, very long, but when you're working as a professional modeler, those kind of delays would feel really, really sluggish. And it just doesn't really make it practical to use the edit mesh geometry types as the basis for a sub-D modeling system. All in all, the edit mesh system is far from ideal for sub-D modeling. However, the edit mesh architecture is just fine for mesh creation, for storing any kind of Cyberscan models, and also for tessellating any primitives that we have in our scenes. It's great for that. It's absolutely fine. There's no real problem about using edit meshes for that. So it's very much alive and kicking in 3ds Max. In the chapter after next, I'll explain more fully the differences in editable poly and its pros and cons. I'll also show you in practical terms its differences to the edit mesh. For now though, let's have a look at making some polys from scratch using an object that's been converted to an edit mesh. Before we do that, here's a quick interface tip. Often when you're working in 3ds Max, you may find that the rollout for any modifier or for basic object type is very, very large. And this is certainly the case with edit meshes, and especially so with edit polys. It's nice though to have most or all, if you can, all of the options on screen at the same time, because when you're modeling, you don't really want to be digging through lots of rollouts to try and find a certain option. We're lucky today because we have very high resolution monitors. For this DVD, I run my screen at 1280 by 1024, which is the standard resolution recommended by Autodesk. But when I actually work in the real world, I run my monitor at 1600 by 1200, which I find is pretty good for my eyesight. If I had a higher resolution monitor, I could try, running at 1920. But I run it at 1600 by 1200, and I have two monitors, and they're both at 1600 by 1200. I have acres and acres of space. So what I do is I grab the control panel and I pull it out to give myself more room for the modifier parameters to be shown. So let me just show you how you do that. It's very easy. Just go over to the left hand edge of the panel, hold down left mouse button and drag, and you can just drag the panel out here. And you can pull it out as many times as you want, just make it as big as you want really. Obviously, what I've done here is maybe a little bit ridiculous. It's, I don't need that much space. That's obviously overkill. But, I would certainly pull it out twice. And if I was running in high resolution, I needed all the options from a large tool to be visible at one time, then I could pull it out 3 times. But for now, let's just settle with 2. And that should be enough kind of acreage for us to do some modeling here. Okay, well, let's make a start on doing some mesh editing now. And the first thing I need to actually do any mesh editing is an object. And in this case, we need a primitive. Now, the reason for that is a primitive uses polygons to display its geometry, and we need polygons to turn into an edit mesh, so it makes sense that we use some kind of primitive to give us that. Now, in this case, I'm just going to use a box. It doesn't really matter actually what geometry I use here. What I'm after is a 3ds Max object which has polygons in it, and the box has that. It's got a transform, and then it's got a geometry description attached, and that description is of this box, which you can see is displaying in polygons. I'm going to be editing it in edit mesh mode. That means that the object will be an edit mesh. So I can do that in 2 ways. I can either convert the object into an edit mesh by using right click and going down here in the quad menu and using convert to edit mesh. Or the other option is I can use a modifier. So you can see in the modifier flyout, I've got edit mesh here. I can apply that. Now, there are different advantages to doing things either way, but the main one with right-clicking is it's quick and it's light. It doesn't use any real overhead. It just turns the object very quickly into an edit mesh. Doesn't have any modifiers, keeps the stack very simple, and so on. The other option, using the modifier, has its advantages in that you can actually turn it off. So if you make any modifications to this box, say if I went in and I deleted some faces, just delete those faces there. If I didn't want to see the result of that edit, I can just go in and turn off that modifier, and I'm back to my box again. So in this case, we're just going to go for a simple mesh. So I'm just going to right click, convert to editable mesh, and there we have a basic mesh that we can start to edit now. Now, if I wanted to, I could go in and I could select all of these faces, make sure I've got everything there. That's very important actually when you're modeling, that you make sure that your selection is what you actually thought it was in the first place, because it's very easy to make selections and you think you've got the polygons that you want, and in fact you may have more or less. So it's always a good idea to verify. Now I have all these polygons, I could delete them, and what this leaves me with is just an object, but it doesn't actually have any geometry. It's still an edit mesh. I haven't actually destroyed that part of it, but it hasn't actually got any vertices, edges, or faces. So, and it's also very difficult to select now. You might not be able to see it. So one way of selecting it would be to use the select by name dialog. So I can just actually select it there. And the other way is, drag selecting over it. But, that can be difficult in a scene where you can't actually see the object. So the obvious choice is to use the select dialog. So there we are, we have our box. And I'm just going to undo those things that I've done just now, so I get my geometry back. And the reason for that is I'm actually going to show you something with these faces in a short while. The first thing is, and I'll reinforce the point that I made earlier, this is a box, a cube made up. It actually had one level of tessellation, so you can see you've got 4 faces on every side of the cube. And when I say faces, I mean polygons, these squares that you can see here. But in fact, if you actually select the cube, you can see that there are some extra edges here. And the reason why those faces are there is because, in fact, this is an edit mesh, so it doesn't really have any concept of polygons, and a four-edged face would in fact be a polygon, a true polygon. So in fact what's going on here is that those extra edges are actually just hidden. It's just a visibility thing. So if I wanted to, I could go into wireframe mode and let me just select these faces. Let me just do that. And I can say make them visible. And now when I click off, as you can see all the edges in the object again. And I'll just undo that. And you can see that when they're invisible, they're shown as being dotted. They have a dotted line appearance to them. And if I wanted to, I can go in and I can actually get some other edges. I'm just control selecting these, and I can say make those invisible. So you can see now that they are invisible. So now we've got the impression that we have, let's see, 1, 2, 3, 4. We have 8 edges on this top area here. So that actually looks like it's a polygon with 8 sides to it. Obviously forming the shape of a square, but in fact it's actually an octagonal polygon. And in fact it's not. It's actually still got all those faces in there. You can see it's actually made up of all these faces. So I'm just reinforcing the fact that an edit mesh is a very simple mesh description, and it's always made up of triangular polys. So if we look over here, I've been doing some manipulations here, and let me just actually take the object back a little bit. There we go. And I've been doing these manipulations via these buttons here, and these represent sub-objects of the edit mesh. We've got vertices, edges, faces, and then we've got 2 special types. These aren't really, classic pieces of geometry of the edit mesh, but they're provided in Max as a way of actually selecting parts of an edit mesh. And also you'll find similar things in the edit poly. So they're actually selection optimization tools more than anything. They're not actually true geometric types. So our edit mesh really is in fact made up of these 3 types here. It's made up of vertices, edges, then faces. Now you can use these buttons here, or the other option is you can actually click on here and this will drop down all of these elements, and this also gives you a list of all the sub-objects. You can see I can select them by choosing from here. And there's also a third option, keyboard shortcuts, which are always very cool. And they are number 1 for vertices, number 2 for edges, number 3 for faces, number 4 for polygons, and number 5 for elements. So let's just quickly show you these in action. Vertices, you'll know from our description earlier on in this DVD, they're obviously the points from which edges are built. You can see I can just grab these vertices and I can move them around. You can see as I move them around, it distorts the faces, the triangular faces, which you have going on here. Now, this is quite an interesting thing actually. If I pull this vertex up here and this other vertex up here, it's actually betraying the underlying architecture of this mesh, because you can see that when I pull up this vertex here, you can see that there's actually an edge here. You can't actually see it, but you can see it's actually deforming and it's causing a fold along this edge. Contrary, on here, you can see that when I pull this up, instead of it folding along here, it's actually causing a peak along here. It's actually quite hard to see, but there you go. You can just about see it there. It's causing a ridge along here, and that's because the edge is actually there. So you can actually see the underlying geometry of an edit mesh, even though the edges are hidden, just by making some deformations there with the vertex. And this obviously makes a big difference to the way this model looks. You can see this produces a certain shape here, and whereas here produces a different shape. So to get around that, you'd actually you'd have to rebuild these faces here, so you actually have the edge running from here to here, rather than running from here to here, if you wanted to have exactly the same kind of deformation on each corner. So even though the edges aren't visible, their orientation is very, very important when it comes to actually manipulating this cube. Now, in a moment or two, I'm going to show you creation of vertices, edges, and polygons. But the flip side of that is also, it's destruction. It's a key part of modeling that you may have to actually delete things sometimes. And you'll actually get quite a different behavior from an edit mesh to an edit poly. Let me just show you what happens here if I select this vertex and I delete it. You can see what happens there is it destroys this edge here. It also destroys this edge here and this edge here. So with an edit mesh, when you delete a vertex, it's also going to delete all of the edges which belong to that vertex. And you get the same kind of behavior in an edit poly. In an edit poly, if you delete a vertex, the edges which belong to that vertex are going to disappear because they need it, as part of their definition. So if you remove the vertex, you're effectively destroying all of the edges which are attached to it also. So now if we move on to edges, sub-object, I can select the different edges here and I can move them around in the same way as before. And sometimes you may find when you're modeling, selecting and moving edges is what you want to do. And in other occasions, you'll find vertices, what you want to manipulate. I mean, if I want to actually change this corner here, it's going to have to be a vertex. But in this case, if I wanted to, let's say, create a ridge along here, I can either select the 1, 2, 3 vertices and then pull this out, or I can just select this edge and this edge, which obviously takes less time. It's just 2 selections to pull that out. So depending what you're doing, you're either going to be, selecting vertices, edges, or faces. Now, let me just show you what happens here if I delete this edge. You can probably guess what's going to happen. It also deletes the faces which are attached to it. And in deleting the edge, I've also again betrayed the underlying structure of the mesh. You can see that it's actually destroyed this edge here, which even though the edge is invisible here, it is actually there. And obviously this is, if I just go here, you can see there is actually a face there. So when I delete this edge, it deletes the 2 faces, the 2 triangular faces that are built using that edge. And you can see it's the same here. If I delete this, as you can imagine, we're going to lose, what, 2 faces? This face here and this face here. Let's delete here. Again, we've lost 2 faces, so you can pretty much guess what's going to happen in most areas around here. And if we click here, again, we're just going to lose 2 faces. There is actually a big difference between edit poly and edit mesh in this respect, because with an edit poly, what you can actually do is you can delete this edge and you won't lose the faces around it. What in fact happens is that you convert the edit poly polygons from, say, a 4-sided polygon into an 8-sided polygon. So, basically, sorry, not 8, actually 6 it would be, wouldn't it? So you lose an edge, so therefore you're left with 3 and 3. But in deleting this edge with an edit mesh, we lose geometry, but with an edit poly, we'd actually redefine this area here into a differently sided polygon. So that's a big difference between the 2 geometry types, and I'll show you how that works when we look at an edit poly later, and we'll do some editing with an edit poly. But believe me, that's actually the case. You can either delete an edge with an edit poly, or you can actually remove the edge using backspace rather than the delete key. And when you use backspace, it actually redefines the polygon rather than actually deleting the edge. So that's a major difference between the 2 geometry types. And if we move on to the third type of geometric primitive inside an edit mesh, we've got the face. And face is made up from 3 edges and it's made up from 3 vertices. And you can see that this mesh is made up from loads of these faces. Now in this case, if I delete this face, what it's actually done here is it's just deleted the face. It's actually left this edge here, it's left this edge here, and it's left this edge here. And it's also left these vertices. It hasn't actually destroyed any of these vertices. All that we've destroyed is the actual face definition. Whereas if I went in and I selected the edge there and then deleted that, it would also delete the 2 faces on either side. So you can see that when you delete faces, you're not necessarily deleting anything else in the scene. You're just actually deleting the face itself. The vertices which are associated with it will actually survive its deletion as long as they're used in another geometric primitive in the scene. I'm talking about, if it's used by another edge or if it's used not by another face. So, that's the way faces behave when you delete them. They're not necessarily going to delete something. So there you go. Those are the 3 main geometric primitives of an edit mesh. As I said earlier, these last 2 options, they're a little bit more non-obvious, as it were. They're a little bit more esoteric, but I'll just show you what they do. The first one is called polygon, and what that does is it doesn't actually select polygons because there aren't any really true polygons in an edit mesh. Everything at the end of the day is actually made up of triangles. But what it does is it selects a group of faces that have no edge between them. So in other words, we've got a face. Let's see. Let me actually look at the structure here. Yeah, we've got a face here. We've got a face here. So if I use the polygon tool and I select here, it's going to select both faces. If I, let's see, if I get this edge here and I hide it, and now if we go back into polygon mode and I select here, you can see it's selected all of those faces. There's actually 4 faces there that it's selected. And that's pretty much the case. As long as there's no edge blocking the selection, you will actually get all of the faces selected. So you can see it's a kind of like a flood fill selection, really. It only selects all the faces inside a border, which you can see here. So generally when you create objects in 3ds Max, Max will actually tessellate them so they appear like this. We'll actually use quads in many cases, and then hide the edge here to actually make it appear to be a true quad. That can be useful sometimes when you actually just want to select that area there. Or if you've got a situation like this, I mean, let me just show you a little bit more what you can do here. Just make that invisible, make that invisible, this invisible, and then here invisible, and then here, oops, there we are, invisible. Now I can select here, and you can see it goes all the way up to here, but you can see it actually won't go across these 90-degree angles here. So you can see it does actually have some limits to it, but I think you get the basic idea with that. And then the last option is the element. This is a little bit difficult to explain, but obviously I'm going to make a good effort here. So let me just get another object. I'm going to create another cube, let's say. Create a cube here. And what I'm going to do now is I'm just going to attach this cube to this cube here. So this basically merges both of these objects into one. We'll lose box 2. It will effectively disappear from the scene, but its geometry will be merged into this one. So I'm just going to go up to the attach option here and pick on the target. And now they are now one object. And you can see that the attach option is still active. So I'm just going to click on that to turn it off. And now we actually have 2 elements inside this object. And let me just show you what that is. An element is an area of mesh which is contiguous. In other words, that means that all of the polygons are attached to all of the other polygons in that object. If there's a break in the object, then you don't have an element there. So this cube, all the vertices are attached to each other. And this attachment concept is something we'll be looking at in a little bit more detail in chapter 3. But for now, we're just going to look at it in terms of, in context of the element. So if I click on this object, you can see it selects it. And if I click on this object, it also selects it. And that's because they're both elements. Now, if I get this cube and actually push it inside this object here, it's got nothing to do with them being separate in space. If I do this now, you'll see that they're both still treated as separate elements. And that's because the polygons are actually separate in these objects. They're not actually attached to each other anyway. So I'm just going to show that with one more example. Just going to create some, let's say, a plane here and another plane here. Just going to shift select that and move it over here. Now I'm going to attach these to these objects as well. So I'm going to go here, attach these planes to this object. So now we've lost those planes, but the geometry is merged in here. If we go in and select these two objects, you can see that they're still elements again. So we've got 4 elements in this object. But if I get these vertices and I join them to these other vertices here, if I merge them basically, and I'll do this just by selecting them and choosing weld selected, we need to increase the threshold for this to work. So let me just put this up until we get a value that works. There we go. So now they're attached together. We've effectively merged these vertices together. Now, because these two areas are attached together by their vertices, they're no longer separate elements. They're actually just one element, as you can see. And I'll just finish off by showing just one last example, which is the teapot here. If we just convert this teapot into an editable mesh, go to element and select, what you'll find is that the teapot itself is actually made up of multiple elements, and that's because the spout doesn't share, if we just go to wireframe mode, doesn't share its vertices here. They're not attached to the body. The lid is not attached. The vertices are not shared with the body as well, so that's a separate element. And the same thing with the handle as well. The handle is a separate element. So if I go back into shaded mode and I click on the body, there's one element, spout is another element, and the lid is another element, and the handle is another element. So that's it. There you go. Those are the sub-object types of the edit mesh. We've got vertices from which are built edges, and the edges define faces, and a number of faces with invisible edges in between is a polygon, and a group of polygons which form a contiguous surface, in other words, a surface without breaks in, where all the vertices are attached together. This forms an element.